Hello, welcome to today's class. And today's lesson is on surd. So at the end of this lesson, you should be able to define a surd. Be able to tell us um, if what you have is, you should be able to identify a surd, actually. Find and identify surd. You should be able to express surd in their simplest form, or we call it their basic form. And we should be able to identify if two surds are similar or they are dissimilar. So how do we define a surd? So we say a surd is a root that cannot be expressed as a rational number. So before this class, we should already have an idea of the different types of numbers, knowing what the natural numbers are, the whole numbers, the integers, the irrational numbers, and the complex numbers. Well, probably I would make a different video talking about the different types of numbers. So a surd is the root that cannot be expressed as a rational number. So they are the roots of rational numbers whose values cannot be expressed as exact fractions. So we know that rational numbers can be expressed as fractions, or we express them as repeating or terminating decimals. So when we have the roots of a number that cannot be expressed as fractions, that cannot be expressed as fractions, cannot be expressed as repeating or terminating decimals, we know that such number is referred to as a surd. So basically, surds are irrational numbers. Since their answer or the result is not a rational number, so surd in itself is irrational. So example, we have root 2, we have root 7, we have 2 root 11. Basically, the roots of prime numbers, they are also surd. Pi is also is an irrational number, actually. Pi is an irrational number. So root 100, is it a surd? Can it be referred to as a surd? Now, we know that root 100 is equal to 10. 10 is a rational number. So it means root 100 is not a surd. Since the result is 10, which is a rational number. The same thing with root 25. So root 25 is equal to, square root of 25 is equal to 5. And square root of 49 is equal to 7. So we know that these are not surds, right? Because their roots are rational. So can you think of other numbers? Okay, if I have root 36, do you think we can call this a surd? No, it's not a surd because root 36 gives 6. 6 is a rational number. So root 36 not, is not a surd. Okay, what if I have root 5? Oh, remember I said the roots of prime numbers, they are surds. So root 5 is a surd. Yes, root 36 is a surd, but 5, it is a surd. All right, so I want to believe that with this, you should be able to identify surds. You should be able to tell if it is a surd or not. Okay, so let's talk about the rules of surds that we are going to be using. We are going to be finding it very helpful as we continue. The rules of surds. So the first is the root a times b. It can be any, we can use any variable at all, but I'm using a and b in this case. So root a times b is equal to root a times root b. Let me use a number as an example. So I have we have root 8 times, now let's have the root 8 times root 10. It is equal to, so what the rule means is I have root 8 times root 10. That's what it should be. Okay, another one, if I should have root 2 times 5, it is important to know that it is equal to what? Root 2 times root 5. Thank you. Okay. Also, you need to know that if I have root 7 times root 3, now I can combine this to become root 7 times 3, which is equal to root 21. So it is important to know this because it's going to be helpful. So when we're multiplying two numbers under the radical, okay, I didn't mention that this is also referred to as the radical, this. So when we're multiplying two numbers under the root sign, we can split it up. So that gives us root 8 times root 7. I believe that is clear enough. Okay. For the division, what if I have, in this case, I have roots A over B. Mind you, it can be a cube root, it can be a square root, the fourth root, the fifth root. Right? So generally, I'm just using roots. So root A over B is equal to root A over root B. What does this mean? It means if I have the square roots, this time around I'm using square roots. So if I have the square roots, in fact, okay, let me put this here. The square root of 4 over 25, it means I can have it as the square root of 4 over the square root of 25. Now, we know that the square root of 4 is 2, and the square root of 25 is 5. So it means the answer is 2 over 5. Exactly. Okay, let's take another example. I may have to wipe this. I have the square root. Okay, let me make it a cube root this time around. The cube root of 27 over 125. So we should know that this is the same thing as the cube root of 27 over the cube root of 125. And the cube roots, what number do you multiply by itself 3 times to give 27? So it's 3. 3 times 3 times 3 gives 27. So that's 3 over, now the cube root of 125, it gives 5. 5 times 5 times 5, that gives 125. So the cube root of 125 is equal to 5. So that's 3 over 5. I hope that is clear. Also, it is important to know that if I have it this way, let's say I have root 8 over root 8 over root 50. I may decide to write it as, now let's say the square root, let's say the square root. So I may decide to write it as the square root of 8 over 50. We'll look at this shortly. So with this, you can see where I have the roots separately. I decide to combine, have the numbers under the roots because I can further simplify this to become, simplifying this, I have the root of, this can be divided by 2, this can be divided by 2. So I have 4 over 25. Now remember what we did earlier, right? So this can now, see this, it can be split this way. So I can now have the square root of 4, which is equal to 2. And I can also have the square root of 25, which is equal to 5. Now we're going to look at problems like this soon. I just want to explain how we make use of the roots because we are going to find this useful. Okay, so I want to believe using these two rules becomes very easy for you as we continue. Let's progress into the basic forms of surds. The basic forms of surds. Now, what does it mean when we want to put surds in the basic form? expressing surds in the basic form is expressing it in the simplest form. So when you consider a number like root 18, and 18 can be expressed as a product of two numbers such that one of the numbers is a perfect square, right? That's what, once we're able to do that, it makes our work very easy. What do I mean? Root 18. Think of two numbers I can multiply. The product of two numbers that gives 18, such that one of the numbers is a perfect square. Now, I think it's root 18 is equal to, now, the root of 2 times 9. Remember, 9 is a perfect square, right? So with this, we can go back to this rule, remember? So now that I have root 2 times 9, so I can express this as the root of 2, that's the square root down, times the square root of 9. You see that? Now, the square root of 9 is 3. So it means I have root 2 times 3. Now, root 2 times 3 is equal to 3 root 2. That gives 3 roots. So we have been able to express root 18 in the basic form. So root 18 is equal to 3 root 2. I hope you find that easy enough to do. All right, so pause this video and you do the square root of 45 and let's see what you have. All right, so what do you get? Okay, let's see. So for root 45, two numbers will multiply such that one of the numbers is a perfect square because that makes it very easy. So you should think of root 45 equals, what do you have? 9 times 5, yes. So that is equal to root 45. Sorry, root 9 times 3 becomes root 9 times root 5. Now, root 9 gives us 3. Now, 3 times root 5 becomes 3 root 5. So it means that root 45 in the simplest form is the same thing as 3 root 5. I hope that is clear enough. Okay, now I will do this. Root 98. Root 98, I know that root 98 is the same thing as having 2 times 49. And that gives root 2 times root 49. So with that, I know that root 49 is 7. The square root of 49 is 7. So 7 times root 2. That gives 7 root 2. Now, take note, it is 7 times root 2, not the 7th root of 2. If it is 7th root of 2, it will be written as 7th root of 2. But that is not the case now. What we have is 7 times root 2, which is 7 root 2. So root 98 is equal to, in the basic form or in the simplest form, is 7 root 2. All right, so let's look at the case where I have a number like this. That's 2 root 150. Now remember, 2 root 150 is the same thing as saying 2 times. So I think that's the first thing we should do. We can have it as 2 times root 150. All right, so what number do I multiply? So this may be a little bit complex in the sense that you're thinking, okay, 150. What numbers do I multiply to give me getting a perfect square and a number? It may be a little bit challenging, but I will show you something. 150. So think of any number at all that can divide 150, the simplest number. Okay, so you think of 2, that's fine. So it means I know that 150 is equal to 2 times 75. But we know that we cannot find the square root of 2, neither can we find the square root of 75. So let us see how we can split 75. So if we should split 75, I still have 2 times. So what's the simplest number that can divide 75? 3, right? So now we know that it is 75 can be written as 3 times 25. So with this, it becomes easy because I know the square root of 25. So what I just have to do is 2 times 3 is 6. So it means I can write this as 2 times root 6, or I can say 25 times 6. So this is another way you can do this, such that it becomes easy. So I know the square root of 25. The square root of 25 is 5. Remember, I have, okay, let's use our roots. Remember, we have 2 times square root of 25 times square root of 6. Now, square root of 25 is 5. So it means I have 2 times 5 times square root of 6, root 6. So 2 times 5 is 10. So that gives me 10 root 6. So it means 2 root 150 in the simplest form can be written as 10 root 6. I hope that was not too difficult to do. Okay. I need you to do 3 root 72. Remember, 72, just look for numbers you can use to divide 72. That makes it easy. So pause the video and try it out. Okay. Let's see. Remember the approach we used, 72. So I'll think, how can I break down 72 so that it becomes easy? I know that this is 3 times root 72. Now, 72, I can write it as 2 times 72 divided by 2, that gives 36. That's quite easy. So I can simply write it as 3 times root 36 times 2. Now, based on the rule we learned earlier, so that is 3 times root 36 times root 2. Now, the square root of 36, that's quite easy. That is 6. So that is me having 3 times 6 times root 2. So that gives us 18 root 2. So that is 18. So it means expressing, remember, what we are doing is expressing our surds in their basic form. So it means 3 root 72 in the simplest form or the basic form is 18 root 2. All right, so another example on this. So 5 root 200. This is quite easy because we just know that 5 times root 200, it can be written as, now 200, it's quite simple. That's 100 times 2. 100 is a perfect square. So I will have it as 5 times the square root of 100 times 2. So it means we have it as 5 times square root of 100 times 2 is something as square root of 100 times square root of 2. So that gives me, so that gives me 5 times square root of 100 is 10 times root 2. 5 times 10, that gives 50. 50 times root 2, that is 50 root 2. So it's as simple as that. I hope it is clear. So when you are asked to express surds in the simplest form, you know what to do. Okay. What if we need to express surds in their single form? What do I mean by that? That's the next thing we'll be looking at. If I need to express surds in the single form. Now, when I say in the single form, we have something like this. Root 18 is in its single form, right? Root 45. So is it I say it in its single form or complex form, actually? So back to this. So how do I do that? So it's just like me moving from I want to move from 3 root 2 back to root 18. Or I want to move from 3 root 5 back to root 45. This is very simple. Very, very simple. What do I do? 2 root 5, the easiest way to go about this is simply do this. 2 root 5 is equal to, now, have your roots, 2 squared, that's 2 to the second power, times 5. And that gives us root 2 times 2, 2 to the second power is 4. So I have 4 times 5. And that gives root 20. So I know that 2 root 5 in its single form is root 20. So I need to pause this video and attempt this. So you have to do 5 root 3. Okay. What do you have? Let's see if you are correct. 5 root 3. What do you do? So I know that 5, okay, now let me divide this way. 5 root 3 is equal to, have your root sign, 5 to the second power times 3. So that is equal to the root, 5 to the second power is 25. Now 25 times 3. And that gives root 75. Yes, that gives root 75. Okay, so I'll be doing this. 2 root 10. Looking at it real quick without solving, you should be able to give the answer. 2 root 10, that is 2 root 10 can be written as the root of 2, this 2 to the second power, times 10. I know that 2 to the second power is 4, so I have root 4 times 10, and that gives root 40. So I want to believe you found this very easy to do. So you should be able to attempt 2 root 7, 7 root 6. So as not to make this video so long, so I would advise you attempt this. But you should have root 28 as your answer. Now, if you've done this properly. So attempt this 3. Now, why do we need to understand how to express surds in the basic form? Why do we need to learn that? Expressing surd in the basic form or putting it in the single form. Why do we need to know that? The reason is because it helps us to identify if 2 surds are similar or not. So the knowledge of that becomes useful. So let's see. For example, can we say that root 18 is similar to root 45? Let's see. Let's talk about similar surds. Let's talk about similar surds. So when we have surds with the same radical parts, they are called similar surds. Now, in the simplest way possible, if I have 5 root 8 and I have 9 root 8. Now, the radical parts, this is what I mean by the radical part. So I have root 8, I have root 8. So we can say that these two surds, that is 5 root 8 and 9 root 8, they are similar, right? But in the case where I have 3 root 2 and I have 2 root 3, can we say these two surds are similar? No. What is the radical part for this? The radical part for this is root 2. The radical part for this is root 3. So when we consider this, they are not the same. So we cannot say they are similar. So they are not similar. Now, the knowledge of this will be useful when we are adding our surds and when we need to subtract surds. Right? So it is important to be able to identify if surds are similar or not. So we have a problem. It says root 18, root 32, root 50 are also similar surds. How? Let's see. So root 18. Remember, we can simplify root 18. Having root 18 in the simplest form, that gives us what? Remember, it is the same thing as having the root of 9 times 2. And of course, that gives us root 9 times root 2, which is equal to root 9 is 3. 3 times root 2, that is 3 root 2. Now, that's what root 18 is. So root 18 is 3 root 2. Let's see what root 32 will give to us. Root 32. Now, root 32 is the same thing as having 16 times 2. And that is equal to root 16 times root 2. Now, square root of 16 is 4. Then 4 times root 2 is 4 root 2. Now, look at this. The radical part is root 2. The radical part is root 2. Okay? Now, let's see if root 50 have the radical part to be root 2. Root 50. Now, root 50 is equal to the square root of 20 times square root of 2. Square root of 25 is 5. Then 5 times root 2 is 5 root 2. So you see that they all have their radical parts to be the same. Root 2, root 2, root 2. Right? So we can say that this surds, all of these, we can say they are similar. We can say they are similar. So we have a question. Are the following surds similar? Okay, so because of our time, I may not be able to do all of these, but I will take about 3 of these questions. We'll look at them together. Root 125, root 75. I want to check if these two surds are similar. Okay, so root 125. That is equal to, we did that earlier. So that gives us root 25 times 5. And root 25 times root 5. Now, root 25 gives us 5. So 5 times root 5 is 5 root 5. That is root 125. Okay, let us see for root 75. What do we have? Root 75, numbers are multiplied to give me 75. Okay, so that is 25 times 3. Now, this gives the root of 25 times the root of 3. Now, root 25 is 5 root 3. Now, you see that this is 5 root 3. This is 5 root 5. Now, the radical part is root 5 for this, and the radical part is root 3 for this. So we can see that they are not similar. So, are the following surds similar? No. They are not similar. Now, you should do root 200, root 45. I need you to check if they are similar. Do you have them to be similar? Okay. Let's check. So root 200, we know root 200, that's quite easy. That gives us root 100 times 2, which is equal to, now from this point, I know that I'll look for root 100, then root 2. So root 100, I can simply have it as 10 root 2. Yes. What is root 45? Root 45 is equal to root 9 times 5. Square root of 9, that is 3 root 5. Are they similar? No, they are not similar, because the radical part for this is root 2. The radical part for this is root 5. So they know they are not similar. All right, so you should attempt the next one. Let's see what we have for this. I will be doing this. Yes, let's see what we have. So root 160 and 2 root 125. We want to compare if they are similar. Let's see. So remember, I said something earlier. If I have 160, two numbers I multiply, right? So what comes to mind is it's quite easy to think of 16 times 10. Now 16, we cannot find the square root of 16, right? So it means I can have, root 160 to be equal to root 16 times 10. And that gives us root 16 times root 10. Now, root 16 is equal to 4. 4 times root 10 is 4 root 10. Okay, let's see 2 root 125. I think we already did 125 times 5, which gives us 2 times root 25 times root 5. And of course, that is 2 times root 25 is 5 times root 5. And that is 10 root 5. So we see we have 10 root 5 for this. We have 4 root 10 for this. So are they similar? No, they are not. So we know that root 60 and 2 root 125, they are not similar. So I need you to attempt this, check if they are similar, attempt this, check if they are similar, and also this, check if they are similar. Right? So the knowledge of similar surds will be very important in our next video, because that will be the next lesson is on, we're talking about the addition of surds, the subtraction, the multiplication, and even the division of surds. So I hope at the end of this video, you are able to identify surds, you are able to express surds in their simplest form, and you're also to identify if two surds are similar or they are dissimilar. So that brings us to the end of today's class.